Alright, so first thing we're going to do today is I want to ask you about, are you experiencing any issues with the moon project phase that you are currently doing?
False.
False. So everything's going well? Okay.
No,
Truly false. Is anyone having issues at all? No? Okay. What are some of the things that you like about it so far that you're doing well at?
the classic.
Either or.
The moon's cool.
Moon is cool. It's actually literally cool. It's not a hot thing, so yeah.
Is it bad that I missed it 3 nights in a row?
Yes.
Probably.
Yes.
That's probably not good. Yeah, I think from what I understand of your professor, she very much expects you to be on task with that, and that could very well affect your grade. And professors tend to be stricter on grades than high school teachers. They're kind of much more apt to fail you on something. So, how about the rest of you?
The quizzes aren't bad.
Okay.
So that's nice.
What are the quizzes like?
I'll let you know. I'm not a quiz taker.
You're
But
not
I'm
using
not putting on a quiz.
Good. What are they like?
Very easy.
I think
Just as long as you read the stuff.
Okay.
Yeah, as long as you read it. I'm not a note taker. I'm not having to take many notes.
Okay, that's good. It's actually really good. It sounds like as long as you're just doing the work, it's not like a hard class. That's really encouraging. Okay, so we're going to move on to our next subject for this week, and I'll start with this. Over the next 10 to 15 years, a number of space exploration missions are dedicated to finding exoplanets with the hope of discovering life somewhere in the universe. Technology has allowed man to explore beyond the confines of Earth in search of the possibility of life outside of planet Earth. Advancements in technology have allowed man to study possibilities with telescopes, rockets, space stations, and satellites. Future missions are planned to again send a man to the moon and even to Mars, but as you can imagine, this is not cheap. So, as a question, which countries do you think spend the most on space exploration?
Russia.
Okay.
China, America, right there.
So, Russia,
I say Russia, China,
her, Japan,
Because they're always doing the movies.
US, China, and what was the fifth one? I thought I heard the fifth one, maybe not. Okay, so these four pretty much?
Zimbabwe.
I'm kidding.
I'm gonna make a
Well,
guess and say Zimbabwe is probably not as much as these other countries. Maybe they have a space program we don't know about. Okay, how much do you think each of these countries spend on an annual basis?
I would have to guess it's in the billions, but I don't.
U.S. spends the most.
Okay, let's just do it this way. I'll try to.
I'd
I
actually,
don't think so.
I might argue that China is.
Yes. They do.
Give me a rough estimate.
13.8 million for the U.S.
13.8 million?
Million or billion? I would have guessed billion.
Billion, 13.8 billion.
Not billion?
I don't know.
I don't know if it's that many billions, but I feel like it's in the billions.
Million or billion?
I say million.
Million? Okay.
Dude, a few years ago, the military spent more money in air conditioning in Afghanistan than NASA spent in their entire figures.
Alright, how about Russia, Japan, and China? Rough estimate,
You're
yes.
right. You're probably right. Do what?
Just for fun, rough estimate.
China, 18 million.
18 million. Okay.
17 billion yen. You gotta do it right.
We'll say 18 million.
Why are Japan and China up there? Shouldn't that be the same thing?
Russia and Japan?
Shouldn't Japan and China be the same thing though?
No.
Dude,
Japan and China have different.
You're making a lot of people mad saying that.
Sure, North America and South America be the same, right?
Yeah. They're very, very different cultures. So. Okay, anyone want to guess Japan?
15 million. Or no, 9 million.
9 million, okay.
9 million.
17 billion for Russia.
Just for fun, we'll put that up.
No, okay, that's it.
Might be right.
That's up our graph.
Never know. Okay, so according to worldatlas.com in 2013, the major players in the space industry spent a total of $66 billion.
Hey! I got it.
66 billion total. So in other words, the numbers were
What did I say?
a little bit less there by a whole set of zeros. Okay, so let me see the space exploration PDF. Well, let me get that real quick. I'm gonna have to pull this up. Thought I had this one pulled up and I did not. Space exploration spending. Why did this not come up? Ah, here it is. There we go. Okay, I'll pull this up on the projector screen here. And you'll get to see the actual numbers. Actually, to be fair, you got 4 of the countries. Right, so good for y'all.
Can I go ahead and guess who's the 5th one?
Well, it's too late now, but to give you an idea, I'll erase these in a bit. India, believe it or not, is the 5th country.
Really?
Yep, and Japan actually spends less than India, so the actual numbers.
Did I get Russia right? Home with Billy.
The USA
Oh my God.
by
Wait up now.
far.
Hey, I got closest.
Yeah.
Thank you.
So 39 billion is what the United States spends on space exploration. China is the second most at 11 billion, Russia 9, India 4, Japan 3 billion. So you actually, to be fair, had guessed the countries right. The pricing was a little bit off, so that's okay.
That was very
All right,
close.
so you can turn the lights on now. We'll turn this one off. Yep. So for the time being, I'm going to keep this off just so we can see the screen. Okay, now, so let me ask some questions that we're going to discuss here. Should we, as the United States, be spending so much money on speculative research in outer space?
No.
You see, I don't know what they're trying to do, so.
We're not getting anywhere, so no.
Yeah.
We have a contest.
Well,
here.
I don't know if all the money is being put to this exact use that it should be. I guess,
That could be
in my
like
view,
a
it could
little
be used more efficiently for more valuable things. But in space exploration, thinking that the government's budget every year is $4 trillion, I think that's fine in retrospect to what
Okay.
is
So
spent on it.
explain to me, like, what might some of the reasons it would be good that we have such a high spending budget in space?
One of the biggest things, I guess, is resources.
Resources. Okay.
And mining it on the moon or Mars or asteroids.
So theoretically, if we were able to get to other planets and stuff, we would be able to mine them for all sorts of essential energy resources, theoretically. Okay? What might be some other reasons we want to get out there and explore space?
Yeah, basically just to know.
Just to know? Okay.
For just knowledge, just to know what's actually there.
I can also provide a third one, which currently our administration is delving into, and that is military.
Yes.
Military strength. Okay, so the higher, you've heard of the term, I have the high ground. Well, that translates even into space. The higher up you are, the more dominance you have because you have the high ground. So essentially, if you have the ability to put your satellites and your military installations wherever you want from space, you have a lot of control. Keep in mind, that's a pretty scary kind of thing. Imagine if someone said, well, I've got a laser, and all I have to do is type in a set of coordinates, and like that, you're dead. They pretty much already have that technology. That's how creepy it is. So, and they could use that.
I didn't think we were going with that. I didn't think we were going to that aspect of it. I thought
It may not be,
I thought we were moving
but the
towards
same
like
technology.
colonization of Mars kind of stuff.
Well, we are, and
Not-
the same technology though, and the same funding that goes
Satellites.
into space exploration, that's included. In fact, you've probably heard about the Space Force, which is now it is becoming a branch of the military now. We've got the Marines, we've got the Air
What
Force,
are we
we've
gonna
got.
fight?
Huh?
What are we gonna fight?
It's already-
It's about having military dominance in space.
It's already hard. It's not really a branching yet, but
Yeah,
it's
it's
already little.
Yeah.
It's
Yeah.
already at that.
It's a budding branch essentially, from what I understand. It might be based off Air Force, but I think it's actually its own thing now. But essentially, yeah, the whole point of it is not that we're going to fight spaceships, but that
Yeah,
we will
like,
have
we
dominance in the globe. Which again is kind of a scary thing when you think about it. The question is, should anybody have that kind of power? Okay, so should we be wasting money on what some consider to be more of a luxury when it comes to space exploration?
I think that we should cut that cost in half. I think it's a little much.
You think so?
Yes, yes, it's a little much.
I like that we got a person who's very strongly in favor. That's
See, but
good. That's a good thing.
this stuff excites you. Space bores me. It's just a bunch of nothingness. So.
Well, it depends on how you look at it. I mean,
Or you're exploring God's creation.
yeah.
And-
I mean, that's a
And
great
you
point.
can do that with half the budget.
Well, I mean, he does bring up a good point though, is, okay, so, science is the exploration of natural law, right? No matter whether you're Christian or not Christian, you're concerned with natural law. In our case, being Christian, it's natural law as God's creation. He created this law. So is space not also included in that?
It is.
Yeah, and that's something to think about. Maybe we should be trying to understand more of it. Is there a certain limit to what we should spend on it? Maybe. It really depends on, are there higher priorities right now?
Yes.
That becomes another question. Is space eventually going to be so useful that we're going to be glad we spent all the money on it, or is it going to be just years and years and years of lots of money and not really much return? So, again, we don't know, but something to consider. So, okay, so should we be focusing on more down-to-earth problems like climate change or world hunger and poverty rather than parking at another rover on Mars?
The government spends so much money on other stuff that is much, much less important. They spend a lot more on it, in my opinion, a lot more on it. See, it's not important at all.
Okay.
And I think if we're kind of talking on that subject, we can cut some of those things out of the budget.
I like that response too. We can just cut out this thing right now, so we don't need global warming.
So world hunger is less important.
Yeah, see, now he makes a very good point. Should we be concerned with what's going on outside of the Earth, or should we really be focused on kind of Earth first deal? Like, let's make sure we've got Earth down, then move on to space. That's another, interesting question.
Yeah,
But are we
I
ever
mean,
gonna
global
have,
warming, personally, I could care less.
are we actually ever going to have Earth down? Like,
Probably not. I mean,
no matter how much money you throw at it, are we actually ever going to get anywhere?
Well, it depends on how you look at it. Like, we've definitely made great strides, but of course, the world is always going to have its share of problems. I mean, that's just part of how it works.
Give me an example of how you would, Casey, give me an example of what you would do.
Yes, Casey.
I'm just saying, what is an example of what you would use the money for instead?
Not space exploration.
Wow.
There's other things that can occur
Do you think
that
of
are
anything?
more important.
What?
Like not space exploration, because that is, what is that benefiting us? Not much. Bennett, why should we continue to use the money on space exploration?
I've said it what was the point of Columbus coming to the United States? The same thing. What was actually the point?
He does make another good point. Exploration has long been a fascination of the human race and has led to a complete change in the procession of history. Now it's okay if you don't particularly have an interest in it, but the people who have made great strides. I mean, that is true. I think the question of space becomes, well, based on the progress we've made, how useful is it to us now? That's hard to, humans are very much a kind of, I need something now, I need to know what I can get out of it now. And because space, it takes so long and it's so expensive, it's really difficult for a lot of people who look at the progress and say, well, nothing's happening. Now, things are happening, but it's not being discussed in the same way. And the general public, most people don't know about it. And a lot of stuff is classified. A lot of stuff they find in space, a lot of the resources they find, all that stuff is classified. And so things that the public would be like, whoa, we need to know about this, they just don't. So, but what were you going to say?
No, yeah, I was saying that, I forgot.
Okay, so with that said, let's use this chart to basically label some of the pros and cons. And we'll discuss, I'll actually mention a few of them while we're talking about it. Okay, and then I'm going to use a blue one, we'll just go. Alright, so name me either pros or cons of space exploration. You can give kind of short if it helps.
It's not going anywhere.
Alright, so we'll put that up there in your opinion. It's slow or little to no progress.
I guess the cons would be little to no progress. I mean, someone could argue that. I don't know if I agree with that, but someone would say little to no progress, or like, it's not going to end up yielding anything important or valuable.
Okay.
Exactly.
Okay, so it may not.
Someone say that could say that.
Well, it's the truth. That
What
was
you
it.
just said is you may not know of all the progress that's happened. happening. So maybe
Oh, okay. let's
So
see.
here's how I'll write that. It may lead to nothing essential.
It
may.
could lead to nothing essentially.
I mean, we can.
It most likely
resources
will
too.
lead to nothing.
That's the other thing.
Like in the Pluto article, it talks about, or previous articles, it talks about mining minerals from like asteroids and meteors and other planets.
Which have valuable
Which
resources.
we don't
that-
have on Earth.
Okay, then do that.
So a pro then would be a potential resources.
Right, and the more planets we discover, the
Okay.
more resources.
So really
we have,
endless potential.
the more we can help
With
Earth.
half the budget.
How we can do that with half the budget? How we gonna
Figure it out.
1,000 miles into space with half the budget?
Figure
Or
it
that brings
out.
me flashbacks of the SAT like reading. Remember that one about
Oh my
Yeah, I was only four stories.
Alright, so endless potential resources, possibly. What are some other suggestions? Pro or con?
That costs too much.
Okay, that is a to be fair, that is a really fair con. A high cost. I mean, major budget cost.
But it costs very little to nothing compared to what.
Excuse me, 39, whatever that was, billion is a lot.
39 billion
It
is
is,
a lot.
it is, but what else does the government spend billions
A
on?
lot of stuff.
Sure.
And if you
So
put
if we're gonna cut billions
That
places,
are
why are we
more
looking
important.
towards the space exploration to cut first?
And I think it was,
Because it's less important.
I think it's I want to say
To be
it was
honest,
Obama.
I don't know if I would say that, I might say that the military, keep the military with it.
Mhm.
To be honest, I'd say that being a
Although
world
we should
power-
label that as a potential pro is military dominance, military strength.
And that's the other way you could look at it, is it's just an extension of the military budget. When you're talking about satellites and things like that within the
Yeah.
atmosphere.
I'm trying to think, I want to say it was President Obama who I believe made cuts to NASA, which was a major, and I can't remember exactly how he cut
Didn't
it.
he build, this is so random, didn't he build a zombie apocalypse number or whatever?
I have no knowledge of
No,
that.
it was Trump. I know that Trump was in North Carolina or something in a bunker in a hotel.
Sorry, that was random, I don't know why I thought about that.
We'll list the pros and cons of a zombie apocalypse next week or something. Any other ideas? Any other contributions?
It's basically pointless.
You don't know
Let me put it this way. Rather than basically, I would say possibly pointless. Possibly.
And you don't know that
pointless.
either in it, so.
I can definitely tell Kason is 100% in one party here. he's totally biased. But we've got another gentleman in here who is also biased, which is good. I mean, that's, yeah, he's biased in the other direction. But that's okay. That's okay. It's good to have strong feelings about
Maybe
these
Elon
things.
Musk can get a room.
Any other pros that you can think of besides potential resources and military strength? We already discussed one a little bit. You kind
I'm
of
winning
mentioned
your
it.
minute.
Do I?
I'm winning. Go ahead. Get some
I
pros.
might argue that the high cost isn't one though. And I might also argue that may lead to nothing, essential and possibly pointless are both the same thing. So technically there's 2 and 2.
No, it's 3.
No.
Actually, no, he is right. These two are basically redundant.
Yeah.
He
And
is
high
right.
cost, I would argue that if we're gonna cut something from our budget that's high cost.
The high cost,
do
It's
cut
something
that.
else.
That costs too
the
much.
high cost I would still leave as a con because it's still a detriment. Like even if there are other programs that do that, I mean, I would argue it's a detriment to all the programs. A high cost is an unfortunate side effect of something that you're doing here. That keep in mind, just about everything is going to have a con. That doesn't necessarily mean it's bad. It just means that's an unfortunate, part of it.
Sending people to space is dangerous.
I don't know.
Well, how does
Then you go win it, watch it.
So all right, so
blow up.
here's a third one. Let's switch over.
If I
Can we
had
talk-
the opportunity, I definitely would.
Okay, guys. So let's talk about a third one, which is kind of a big one, which is, let's say for the sake of argument, I think we pretty much agree God created the heavens and the universe, right? So, well, heavens and the earth, which heavens being the universe. But if our job, or part of our job, is to try to understand Him more, then space exploration is important, at least to the degree of understanding God's creation from that aspect. So we can put that up there.
Just go outside and hide.
It's fair to say that maybe it's something we should worry about less, but at the same time, I don't know why I was about to say Gads. That sounded like from Boston. Understanding Gad's creation. All right, so understand God's creation. Okay, so There's several pros and cons to either side, and we, unfortunately, just because of who we are, we don't know 100% which way it's going to go. We may end up finding alien life, hopefully Klingons, because that would mean Star Trek is real, and that's a good thing. Or we may end up finding nothing at all. I mean, even if we get to other planets, we may not find any resources that really help us on Earth. Depends. Now, I think they've found some already that are useful, but the problem is getting them here is very expensive. Like, I think they said, like, the rock of the moon itself, like even a chunk from the moon is like worth over $30,000 to $40,000 from just like something that size, and it's like, that is really pricey to try to transport all that stuff. All right, so we're gonna also talk about some of the advantages that are mentioned on this list. Okay, so here's something y'all might not know. Space exploration actually allows us to prepare for potential hazards. The universe is a vast place where hidden dangers could be lurking almost anywhere, and even if you consider only our solar system, you've got asteroids, comets, and other bodies that could devastate our Earth. Exploring space gives us the opportunity to locate these hazards in advance to prepare an encounter that could help preserve our race. I'll actually go one better. Think about satellite. I mean, how much better has our prediction of the weather, our prediction of things happening in the Earth because of our ability to
Without
see
satellites,
it now?
there would be no weather chance.
Yeah, I didn't say satellites was bad.
Satellites
That's
is space
part of the
tech.
exploration.
It is.
No.
Yes, it is. It's part of space technology.
Okay, well, see, that's necessary. Other stuff is
I'm
not.
glad you have an open mind enough to say, okay, well, there's one aspect that's useful. But yeah, satellite and the usage of satellite is space technology. So, yeah. All right. There are interstellar items to consider. Oumuamua, I hope I said that right. Oumuamua, or as they call it, 11-2008 U1, was discovered by Pan-STARRS telescope in 2017 in the University of Hawaii through funding from the Near-Earth Observation Program. It was originally thought to be an asteroid and then a comet, since it was accelerating up to 10 times as long as it was wide, and these items could create interstellar impacts and shockwaves as well. Okay, I'm going to pass, basically the short term of this next one, it gives us more information about our solar system, galaxy, and universe. Well, yeah, duh, that's kind of the main point. All right, exploring space is one of the few human endeavors that crosses borders. There are currently 72 countries who claim to have a space program, and there are only 3 which have an operating government space agency: China, Russia, and the United States. The 3 superpowers, essentially. Despite the political conflicts that occur between these nations, the capability of producing human spaceflight provides the gold standard for future exploration efforts. Only 14 of the 74 nations who operate in space even have a basic launch capacity, and 6, adding Europe, India, and Japan, have that capability to launch or recover satellites. Because of the expenses and resources needed to achieve spaceflight, the remaining nations work together, and those who have the capability of a full launch to manage this aspect of human existence. So in other words, space essentially brings nations together. It's a project that basically everybody's working on. And that's something else to consider. And we'll add this to the pros list, is it's common ground. It's nobody owns space as of yet. So everybody's working together to explore it. To understand it. In many ways, the oceans are kind of the same way. Not quite, well, no, I guess the oceans are the same way. A lot of countries work together to explore our oceans. And they'll set up international projects and all sorts of things. So that is a pro, I would argue. Okay, we can see humanity in a different way with space exploration. Carl Sagan suggested that Voyager 1 take a picture of Earth while it was 4 billion miles away at more than 30 degrees above the ecliptic plane. In that image, our planet appeared as 0.12 pixel crescent, so basically a very, very tiny dot. All of our conflicts, political battles, successes, failures, love, loss, and life occur on this very tiny microscopic little dot in the entire expanse of the known universe. And Sagan said, look again at the dot. That's here, that's home, and that's us. On it, everyone you love, everyone you know, everyone you've heard of, every human being who ever was, lived out their lives in this dot. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forger, every hero and coward, every creator and destroyer, every king and peasant, every saint and sinner in the history of our species lived here, on a mote of dust suspended in a sunbeam. Really, actually quite poignant.
I watched there's a video. I looked up something about it had to do with the class. I can't remember. And then this popped up and recommended or something. It was something about I can't remember what the name of it was, but it eventually went on to it and it showed you the actual numbers for for how small we actually are, and like did an animation of like zooming out,
It's unfathomable.
I've seen that.
and it showed our Earth and showed Jupiter and our Sun, and then had the sizes compared to what other stars are, and just kept zooming out and zooming out and zooming out, and the stars kept getting bigger and bigger and bigger and bigger and bigger.
Yep. And then when you think about it, I think it was like covering mostly just the galaxy. When you think that's just one galaxy and billions of galaxies, that's insane. Now imagine if by chance, and I think we are, but imagine if we're right about who God is. You know, He created all of that, and yet we are His most precious creation. Think about that. In the entire universe, we are the most precious creation. That's, wow. Just, again, mentally, from a human physical perspective, that is just unfathomable, that kind of love and that kind of dedication to one creation. Okay. Let's see here. I'm going to move on to the cons a bit, because we covered a few of these. Space exploration is access to raw materials, so we got that one. Here's one. Here's a pro. This may not, y'all may not know. I actually didn't know this one. Investments into space exploration actually create economic benefit at home. The governments which provide the majority of our space exploration and infrastructure employ over 20,000 people per agency who make direct positive economic impacts on the community. There are private companies who took the potential benefits of this industry and contribute to this advantage as well, such as SpaceX, and there are thousands and thousands of staff. People from all walks of life contribute to space exploration every day, ranging from astronomers to actual rocket scientists. Even though many of these programs receive taxpayer funding, the wages, manufacturing, and indirect investments contribute over 70% more in overall value at the local level compared to each dollar spent in the United States. These opportunities allow us to explore different fields of study in addition to what is waiting in the universe as well. So that's another thing to think about, is basically it creates jobs. You know, it's a whole different wing of exploration with many different facets and basically different positions that you have to take to be able to make it all work. So that's pretty cool. So if you ever have aspirations to be in the space program, look into that. So, by the way, just as a show of hands, is anyone interested in participating in the space program one day?
No.
I can see that, but hey, that'd be cool. Maybe you'll join the Space Force. Captain Kirk of the Space Force.
It's extremely interesting.
Yeah, for sure. It's good to have an interest in that. So.
I don't think I'm that smart though.
Well, it depends on what you're getting into. I mean, and I'm not going to comment on your smartness at all, because I'm sure you are smart, but it depends on what you want to do, because there are some people that, like, they're more technically minded, they're more mathematically minded, they'll become something of a rocket scientist. But you've also got to have people who have a very creative mind to be able to make designs, understand more about space, and kind of like give new perspectives that we haven't seen. So I would argue that space employment probably encompasses a wide range of people with different mindsets. Look at it, says it right here. Anyone can become a space explorer. Space exploration doesn't need to involve starships, space stations, or intergalactic travel. If you own a telescope and look up at the sky, you can embrace this element of human existence. Our scientists have taken this advance to the next level with the Hubble Space Telescope, which has made over 1 million observations in almost 30 years of service. We have made some incredible discoveries with this technology. We have a better idea about the age of the universe, which is estimated at 13.7 billion years. Images of the deep universe show that there are thousands of galaxies out there. Actually, as far as I understand, it's millions of galaxies, but whatever. It helps us discover 4 of the 5 moons that orbit Pluto. We have a better understanding of planetary seasons in our universe, and it works to peer in... They misspelled peer. It works to peer into the atmospheres of alien planets so that we know what is waiting for us in our future exploration efforts. So, okay, we'll move on to the cons. Let me see if I can get to... Okay, disadvantages. All right. So, here's an interesting thing. One con, believe it or not, is our technology. It's not very good, quite frankly, it's subpar to what it should be to make safe explorations safe. In other words, it's right. It's not at where it needs to be yet, and I'll read this. Several agencies are developing space tourism packages which could take people into comfortable aircraft in the very outer layers of the atmosphere. But that is not an exploration effort. We currently strap astronauts into a vehicle that gets attached to a very large rocket so that there's enough speed to break from the grasp of gravity. Starting with Theodore Freeman, who was killed in the crash of a T-38 in October 1964, there have been over 20 individuals who lost their lives in the line of duty while advancing U.S. space program interests. There have been 2 individuals, Gus Grissom and Pete Seibold, who were able to survive a program that resulted in the loss of a space vehicle. And another thing to consider, which this one actually didn't, I don't think it covered, is essentially anything that you have to get up to space, you know, like technologies, repairs, all that stuff. You know, when you're in space, you're stranded. You know, you're gonna have to wait a while before stuff comes up. So if something goes wrong, you're gonna have to improvise, and you're gonna have to do it very well. So it's right now our technology's not quite to the place where we don't have to worry about a lot of things going wrong. I'm trying to remember. I want to say it was the Columbia spaceship that blew up as it was reaching orbit. It just blew up. Everybody died. 11 astronauts. I want to say it was the Columbia, but I might be mistaken.
The Challenger? The Challenger, wasn't that?
It might have been the Challenger.
That had the teacher on it?
Yes, it was the Challenger. You were right. Okay, so that's it. That's the one I was thinking of, not the Columbia. Okay. So yeah, and then even I'm sure some of you may have seen the movie Apollo 11, where if you like space,
I haven't seen it yet.
You need to. It's a good movie. It's actually fairly historically accurate too to the events, and essentially a lot of complications went wrong with Apollo 11. Now they survived, but just barely. It's very dangerous.
Is that the one where the filters or the rebreathers went wrong or something? So it wasn't filtering out the carbon dioxide in the air.
Yeah.
And
they had to move. They had to move from one nodule of the rocket to another, or the shuttle to another, because they could not survive in the main.
I can't remember. I saw something where it was it was a recreation of what actually happened. Mm-hmm. They got all the engineers in a room, and the head guy pretty much got a box and set it on the table and said, "This is what they have on the spacecraft, and here's a square filter. We need to figure out how to make this a circular filter to be able to fit and then filter out the air because of the carbon dioxide in the air or something."
I believe that was the same event, because what I mostly remember from it is that they had to actually get rid of 2 of the main compartments of the spacecraft and move into the final compartment, and basically it's like, well, it's this or we die. And so it was a very, very dangerous mission, but they did manage to get back. All right, okay. There are cost considerations to look at with space exploration. This is where we get into this very costly. The cost of exploring space is one of the biggest criticisms of the efforts to launch a program that takes us beyond our planet. When the Space Shuttle program was active in the United States, the total cost of the launch of just the one launch was about $500 million. The launch of the Space Shuttle program. Okay. The figure does not include the expenses of postponement that often occurred because the conditions were not right to send a rocket into space. Manned missions in our solar system could cost 10 times that amount, and that might get us to Mars or one of Jupiter's moons. Technology advancements in recent years could make the issue cheaper for the next generation, but we should ask ourselves if spending billions on space exploration is the right thing to do if people are dying of hunger on our planet. I love that it makes the exact same point of the hunger issue.
The biggest thing that I don't think we're going to be able to have people go to Jupiter's moons. I don't know if that's plausible until we have some other fuel or mode of transportation. These fossil like rocket fuel engines, that's not efficient.
Yeah.
It's not efficient enough to be able to get us past Mars.
Yeah.
I'm confident that we're going to be able to get to Mars. SpaceX will get to Mars. I'm confident in that. But I don't know about further than that.
And to some degree, I agree with you. One of the hardest things that we've always had is coming up with a very efficient fuel source. I mean, even on Earth, it's difficult to come up with a very efficient fuel source. Yeah, we could use solar, but you have to have the sun, and you could use water.
I feel that we're going to have some breakthrough in quantum mechanical.
Possibly. Warp drive, right? That'd be awesome.
I've read many articles by NASA scientists that say it's technically plausible.
Well, it's on Star Trek, so you know it's possible.
They actually have equations that they say it's possible if you do it.
That's
actually the only way they have now.
It's theory.
The only possible way where you could go faster than speed.
Well, it's theory, and it could very well turn out to be right. It could. I mean, again, we've come over so many. What's the word I'm looking for? Discoveries that we originally thought, it could never happen. Like originally it was thought if a human were projected beyond 50 miles per hour, they would literally disintegrate. Like at one point people thought if you went faster than 50 miles per hour, you would disintegrate and essentially die. And they proved that completely wrong. And then they were like, well, if you go past a certain G-force, you'll die. And they proved that mostly wrong up until a certain point. Now I think it's like 4 Gs, 3 3G or 5G gravity, where it's like if you're in that intensity, your body literally like shakes itself to death or whatever. It's you go basically you go unconscious. It's I can't remember the exact science behind it, so don't quote me on that. But it's essentially jet fighters, like subsonic or supersonic jet fighters and stuff. They have to build cabins and stuff that compensate for the force that you're experiencing, the speed you're going. Because essentially, if you go too far, you literally pass out, and then the plane wrecks. But the point is that we've come to so many discoveries that we originally thought, oh, this would kill a human, or it's not theoretically possible at all. And then people started, well, maybe it is, and then we proved, yeah, you can do that.
One interesting fact back to the Challenger when it blew up. The funny thing is that the engineers, it was very cold that night, and it had not. It was out of the norm for Florida at that time of the year. But it had been gotten very cold. I think it might have dropped below freezing, but they said there might have been some crack or something in the fuel tanks. The fuel tanks were unstable because of how cold it got. And the engineers told them, do not do it. But there's something, they called it go fever. Everyone was so...
They were already in motion.
They could have stopped it, but they were caught up in it. Oh, we've already gone this so far, we can't stop it now. There's people coming, and we can't stop it now. There's too much on the line right now. And that's what ended up happening. It blew up because of that. But they called it go fever.
Yeah. Now there's one, speaking of cost, by the way, and in materials kind of going into safety and how a certain material that's used for the safety of an spacecraft. Does anybody know what one of the principal materials is used on spacecrafts? It's a resource. Begins with a G. Gold.
Gold.
Pure gold.
Why did I almost say Gatorade?
Well, I'm sure they drink Gatorade.
Gators.
I wouldn't say Gatorade's a natural resource. I'd love to find a Gatorade spring somewhere. That'd be great. But no, gold. So I actually worked at the Delano Gold Museum for 2 years after college, and one of the things we learned is that gold is used extensively on spacecraft because you can actually cut it down to the microscopic level as a layer, and it will actually prevent radiation. And one of the things that like space helmets included will look gold. It's because it's actually a gold layering that's used in the helmets to prevent radiation from penetrating into the dome. And the suits are lined with it underneath, and the spacecrafts are lined with it.
Maybe that's why it's so expensive.
That's one of the reasons. I mean, gold is a precious resource, and they use a lot of gold in space technology. Alrighty, so moving on. Let me see what time we got. We're fine. Okay, if the launching astronauts will receive exposure to natural dangers while in space. We were just talking about some gold. If the launching process doesn't kill you during the manned space exploration effort, then the natural dangers that are present outside of our planet's atmosphere could become problematic in a variety of ways. Radiation that comes from the sun is a constant danger to astronauts when they are in space, and the weightless environment can change their physical conditioning. Experiments with identical twins, one staying in our planet and the other spending a lengthy assignment in space, showed that there are changes at the cellular and genetic level that occur in space. The longer you're in space, believe it or not, your own genetic structure begins to change. I wouldn't go so far as to say you become a mutant or anything like that, but it certainly weakens.
Wait, so they took twins and...
They put a twin, left them on Earth, and then a twin in space, and they compared them both. Because twins have the same identical genetic structure. So, yeah. So you can actually compare them perfectly if you put one in this scenario, one in that scenario. And sure enough, the one who was in space began to deteriorate and change because of extended space-time. We certainly, as far as I understand it, we were not made to live in space, So, yeah, we were made to live on Earth. So when we change that atmosphere, it changes us. In fact, I've always had the theory that if we ever colonize like the moon or Mars or any of those places one day, you would actually see kind of like a completely different, like not human species different, but in the sense of a different structure. Like we would be built differently if we lived long enough in those places, because our body would be trying to adapt to that environment. Obviously, we wouldn't be living outside, but the fact that we're not getting the same kind of sun and the same kind of nutrients we would here on Earth would change us. So, okay. So I think we're going to end it there because we've got a movie we're going to move on to. But yeah, so that I want to tell you about some of the different potential benefits of and cons of space travel. So if you want to be an astronaut, start working on it. Okay. Actually, I find that I was almost an astronaut without realizing it, because I once did a bad thing. My mom said she was going to kick me to Kingdom Come, so I was that close to being an astronaut. So, alrighty. So, let's see here. Okay, so there's much discussions amongst astronomers and the media about the discovery of these things that were mentioned before called exoplanets and the possibility of life on such planets. But not all scientists are brought into the idea that other planets are habitable. Let's see if we can sort through some of the hype surrounding exoplanets with the help of the PBS, wow, I almost said BS program. PBS program Space-Time. Sorry. Okay, here we go. You can turn off the lights if you'd like.
Every few months, the press describes some recently discovered exoplanet as the closest thing yet to Earth's twin. But how much like Earth are these planets really?
Whoa,
and do we even have the...
You can turn the lights back on real quick. I forgot to erase this.
Oh.
That's my bad. Maybe being short.
Same.
I'm learning.
Oh well.
I would know either.
Lizzie, how does it feel?
It's not good, to be honest. It's a climb on a
Well, I guess say in terms of rock climbing, it gives you some advantages because there are tall people who literally can't like squat and reach certain
Yeah.
things.
Ow. He can't climb rock climb.
Yes, I did.
Oh, you're so
You remember me?
bad.
You
He's so
remember
bad.
that?
All right, here we go.
He's late. Ability yet to answer that question. Lots of headlines have touted the discovery of potentially habitable worlds, some of which might be Earth twins. Now typically these stories are accompanied by pictures that look a lot like M-class planets from Star Trek, with a solid surface, liquid water, and a surface gravity that humans could at least function in. But unfortunately, those are all artist renditions. These exoplanets don't actually look like that. Or maybe they do, no one knows. In fact, we have no idea whether any of these planets has water or oxygen, let alone whether you could just walk out of a spaceship and hang out there. It's not that the press or astronomers are lying. There's just a major disconnect between what many people imagine when they hear the phrase habitable world and what astronomers mean by that same phrase. To astronomers, the phrase habitable exoplanet just means exoplanet that lies in the habitable zone of its host star. And the habitable zone, in turn, is defined as the sweet spot of orbital distances from that star, at which the energy from starlight would produce the right temperature on a planet's surface for water to remain liquid, provided the planet actually has a surface and provided there's enough atmospheric pressure. Now the bad news is that being in the habitable zone isn't even remotely close to a guarantee of actual human habitability. For instance, Venus has a solid surface, and it has plenty of atmospheric pressure. Plus, if you expand its orbit just a teensy bit, it would be in the sun's habitable zone. But there's no liquid water there. So is the habitable zone instead a prerequisite for habitability? Not exactly. A planet with a super thick atmosphere, for example, could have surface water in a larger orbit than you'd ordinarily expect. Basically, the habitable zone is more of a guideline, a starting point to narrow down targets of interest. Those estimates you hear of an average of one habitable planet per star in the Milky Way are really just statements about this starting point. But to make a more definitive assessment of habitability, actual habitability, for any of these exoplanets, you have to analyze their atmospheres. And here's the thing. We don't know anything about the atmospheres of any of the so-called Earth-like habitable worlds that get reported in the press. In fact, we can't be certain that they even have atmospheres at all. Take Kepler 186f as an example. In April 2014, this planet got a lot of press as the first confirmed Earth-sized exoplanet in the habitable zone of its host star. These artist renditions make it look pretty sweet. But the only sense in which we've actually seen Kepler 186f is this graph. It shows the microscopic dip in starlight measured by the Kepler telescope when the planet moved in front of its star. By knowing some properties of that star, then based on how much light gets blocked and for how long, astronomers were able to infer the radius of the planet and some features of its orbit like its approximate distance from that star. Turns out Kepler 186f is about 10% larger in radius than Earth in an orbit around the size of Mercury around a fairly dim red dwarf star. So basically, it's a planet like Krypton. Or maybe it's nothing like Krypton, because at 500 light years from Earth, Kepler 186f is just too far away to determine its mass or anything about its atmosphere with current or planned telescopes. All we know are its radius and the approximate size of its orbit. That's it. Sure, you can put limits on its mass by considering extremes of what it could be made out of, and it seems likely from those bounds that it has a solid surface. But the atmosphere is, wait for it, totally up in the air. It could be Earth-like, or it could be wispy and barely there like on Mars, or a carbon dioxide super greenhouse like on Venus, or it could have no atmosphere at all. We just don't know. Okay, what about habitable zone exoplanets that are closer to us than Kepler 186f is? Could we measure properties of their atmospheres and locate a truly habitable world like that? Well, here's where it gets interesting. You can measure the atmosphere of an exoplanet, but not if that exoplanet is an Earth-sized rocky body in a star's habitable zone. Let me explain the problem. To analyze a planet's atmosphere, you need to isolate the planet's light from that of its star and see how bright that light is at different wavelengths. That graph of brightness versus wavelength is called an object spectrum. Since different atoms and molecules emit or absorb particular wavelengths of light only, the spectrum tells you a lot about atmospheric composition. If you combine that information with a planet's mass, radius, and distance from its star, you can use models to get a rough picture of what the atmosphere is like. Okay, so how do you isolate a planet's light? There are two basic methods. First, you can directly image the planet, improving the contrast by blocking out the star's light, kind of like putting your hand over your eyes on a sunny day to help see your surroundings. But this only works for planets that are in very large orbits outside the habitable zone, because closer in, the contrast is still too low. The planet just gets washed out by the star's light. Remember, planets don't glow very bright on their own. The second method takes advantage of what are called planetary transits. You take a spectrum of the star when the planet is in front of it. This will be the combined spectrum of the planet and star. And then you take another spectrum when the planet is behind the star. That gives you the spectrum of the star alone. Subtract the two, and you get the spectrum of just the planet. It's very clever, but unfortunately this method only works for planets that are really close to their stars, because only planets that are close in will get hot enough to glow enough to improve the contrast ratio for that method. So you see the problem. To be in the habitable zone, a planet has to be small enough to be rocky like Earth instead of gaseous like Jupiter, and it can't be either too close or too far from its star, or it won't have liquid water. But unless it is really close or really far, its atmosphere cannot be measured easily, and you can't know whether it really might be habitable. It's a catch-22, but only because of the limitations of current instruments. There was a proposal for a terrestrial planet finder, or TPF, a space telescope that could have analyzed the atmospheres of Earth-sized planets in Earth-like orbits around Sun-like stars. But funding for the TPF was cut a few years ago, so for the foreseeable future, pinning down the actual habitability of true Earth analogs isn't happening. So does that mean identifying the only potentially habitable worlds is a waste of time? No. On the contrary, it's critical. We have to narrow the field, and we need to improve our census of what kinds of exoplanets are out there. It's important science. I just think it's also important to understand that despite what you read, we don't actually have the means to identify Earth 2.0 yet. But we could. The science is pretty much all there. And ironically, if headlines didn't make people think we'd already identified Earth 2.0, there might be more public outcry to make these missions happen. I don't see hashtag I want Earth 2.0 on Twitter yet. So what do you guys think? I know the exoplanet people need to pump up public interest in their work, and the press always needs good stories, but could the current way of reporting about habitable exoplanets be shooting the actual identification of Earth's twin in the foot? Discuss in the comments, and we'll see what you guys have to say on the next episode of Spacetime.
So let's go ahead and discuss that a bit. Let's back out, I think, and then turn this off for now. Okay, so yeah. So we've got a couple questions, well, 3 questions to go over. First is, if there is so much speculation surrounding exoplanets and we really don't have any real information other than basically the size of it and potential mass, why do we spend billions on space exploration, and is it worth it? I know 2 of the answers already, but you're welcome to share them. I mean, go ahead if you want to. That's part of what the class is for.
Just because we don't know enough to that, I mean, we should stop.
Okay, so just because we don't have knowledge of it doesn't mean we should just give up on it, potentially. They could potentially become a major asset in the future, right? That's a fair answer. Anybody else?
I agree with that.
I think you can do it at half cost.
Half cost, okay. So 20 billion instead of 40 billion.
I don't. I think it's expensive to do, and the equipment is expensive. And if we want to find more, we need better equipment.
Then spend less on the gold stuff in the suits. You can lose an arm, you'll be fine.
Do you want all the people to die from radiation?
You can lose an arm, it's fine. Just put it in the necessary parts.
I would suggest that if you don't spend the money on the safety equipment, you'll be losing more than an arm in space. And I think that's one of the issues with the idea of cutting the cost in half, is that if you do that, you eliminate a lot of the safety equipment and the necessary equipment that keeps the already unsafe astronauts somewhat safe. And it's, there's no guarantee. So the less money you put into something, the harder it becomes to make that project a reality. The more money you put into something, potentially gives you more ability to turn that project into a reality. But again, maybe we can pour trillions of dollars and still not get further than what we had. It's kind of hard to decide. Okay, what do you think the ultimate goal of space exploration is?
Find habitable planets outside of Earth.
Okay. Why might that be important?
Well, maybe not so much as to inhabit it, but maybe to use resources.
Okay. I mean, we go back to that, which is the idea that if we find resources on other planets, we don't have to use ours, right? We can just be like, oh, we'll pull from here, and we can actually, quote, save our planet or go green here and still have plenty of what we need out there. Do you agree?
If there ends up being a warp drive engine of some kind, or some other kind of engine that can make it kiss across the universe much faster, say, then do what?
Like something that goes faster than the speed of light.
Faster than speed of light?
Hyper speed.
It would probably, I mean, the only thing I think they know of, it's not classified, is warp drive. And if that, okay. And if that ever,
let's keep it nice here. But to be fair, it's potentially plausible.
They come up with equations and they don't know how to make it happen, but it could happen. So I'm saying until there's something like that, similar to it, or something that it comes to life.
Yeah.
Until that happens, I don't think it's gonna be. I don't think that we're gonna make huge strides into it. But like once we have an engine that can get us to an exoplanet and back 4 times in a day, we can make 4 trips in a day, then
maybe. That I would argue that's probably, even if it's possible, that is a ways off. I mean, we're talking probably centuries, if not more so.
yes, agreed. But if we don't spend the money now, it's
if we
don't
don't
do it now, you have to start.
Yeah, and I think that if there is something beyond Earth in terms of that's useful, and we are spending the money, then I agree with you. It's better to start now than
if you start a marathon. You can't look, oh man, look how far. You can look at the next, take one step at a time.
I think my main concern with something like warp speed is, while I actually believe that it would be possible to theoretically create something that could go as fast as light or faster than light, simply because the existence of matter going faster than light is already a thing. But the issue becomes, could we put a human through that? What could we do to essentially allow a human to not be immediately killed under the pressure or the intensity of going at a speed faster than light? And we've already discovered that even in a pressured jet that's built for that, someone going like 4G could potentially die just because they cannot handle the stress.
Technically, if we're talking about warp drive, then it wouldn't have any effect on the human body, because you're expanding space in the back and you're decreasing space and shrinking in the front of the spacecraft. So the space you're in isn't actually moving.
Okay.
You're moving, it's space against space, moving. It's the fabric space against fabric space, and that's the
bending space fabric is
bending space fabric, and that
I've
we're
heard
not
that
trying to do that yet. They wouldn't have any G-force, because technically you're in your little bubble of space, and you're not actually moving.
Fair enough. Okay.
Yeah, I think we can create warp speed. We can keep a human safe in it.
Yes.
That's also, by the time that we got to that, we would theoretically have the technology to do that. Very possible. Another thing, I don't know if any of you ever watched Star Trek, but did you ever see how the teleporters in Star Trek and how those worked? It was always messed me up, because it was like, they actually explain how they work, and they even show it going badly on one of the original Star Trek movie. But it was the idea that how teleportation would work is that literally you're deconstructed at the molecular level and then reconstructed perfectly. So it's like, so technically you're dying.
Yeah. I was just about
and
to
then
say,
you're basically creating an exact duplicate of yourself. So if you had a soul, potentially that would be gone, and now you've just got a body left that's your exact. I don't know. I'm not sure if that would ever work, but it's interesting to think about.
Didn't they have those in Maze Runner?
I think so.
Where it's like
they would teleport in.
So in the I read the books more than I watched the movies. I didn't watch them, but not as much. It's like it was like a silvery something, and you jump through it and deconstruct it and send you somewhere else and construct your body again.
Yeah, and that's essentially how tech. And I say technology with quotation marks, but teleport technology would work, is that you were deconstructed at molecular level and then reconstructed at the molecular level. Literally, you were being torn apart and then reconstructed back. And it's just like, ooh. So they showed that in the first Star Trek film, which it was a terrible film. It was really badly done. But one of the things they showed is a character being put in the transporter malfunctioned, so literally he's like split in between both. And like they don't actually show him being split, but he's screaming in pain because basically he's being pulled apart. And it's like, oh yeah, I'm good. I'll just fly a shuttle into the planet. I won't tell her. Okay, I think that's about all we have in terms of school stuff. So I'll go ahead and stop the recording. And with what time we have left,